Welcome to the Happy Maths Hour. And I have just realised that I have not invited Toni. I haven't sent her the StreamYard link yet. So we're doing all of this through StreamYard. Now, I have to tell you why I'm wearing this mask. So I was planning to actually take this off during the radio show, and I was seeing the wisdom. I was in the same room, and on Christmas Day, with someone who a few days later got sick. So I just arrived at my sister's house. I'm like, oh my goodness, I've been possibly exposed to COVID and whatever. I've spent the last few days with this mask on in this little room. I've just had a test myself this morning. I have 0 symptoms, 10 days since exposure. So I'm very optimistic about my results tomorrow. But anyway, that's why I'm wearing a mask, and to protect the other people in the apartment that I'm in. So let's see. Got that there. Oh, we've got Mindset Monday. That's not quite, it's not Mindset. Oh, there's Toni. Add to stream. And here we are.
Hello, Caroline. Hello.
Correct.
Oh, I'm going to put my earphones
because I don't have you in my ear. Hold on. Oh no. Hold on 1 second. Hello. Right. I can hear you now. And I've started the new broadcast, but somehow I've still got the mask on. I'm not 100% sure that I'm in the right place here. Okay, I'm sure this is grand. So today, Relax Radio, yes, we're all good there. Okay, I don't see all my bits, and that's fine. Hello, Toni.
Hello, Caroline. Here we go.
So today, it's about odds and evens, and it's as usual, it's a game that's disguised to help even young people get a feel for probability. So we're going to cover that. We've got an hour to do it. So Happy Maths Hour, we're aimed to help you find, using out the Aiming High website and the AimSec resources on Facebook, to provide you with ways to help your young people to become better at maths, to enjoy it, and to help you help them with something that can be quite a big challenge. So after the break, it's going to be over to Toni and the Happy Maths Hour.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us, 24 hours, and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back. Thank you, Toni, for, as always, being amazing. Toni is the person behind all these activities and resources, by the way. I'm just the presenter. I'm just the facilitator of the program itself. And
no, Caroline, we're a double act. We're very much in this together.
I'm glad to hear it. So yes, I have I've explained why I'm wearing this mask. I was, in theory, exposed possibly, yes, to COVID 10 days ago, no symptoms. But until I get the negative results from my test, which is tomorrow. So I'll let you know next week, the results. So Toni, odds and evens. Oh my goodness.
Okay, now I hope everybody can see my screen. Can you see it, Caroline?
No.
Oh, now that is a shame, because I was hoping that this was going to work because we had
did it
tried
last
it.
week.
Yes.
We did it last week.
Yes. Okay. Okay. So share that screen, but that's now back
Okay,
to
that's all
you
right.
and
No,
me.
yes, that's okay. No, I can do that. There you go. It's got to be there for me to be able to show. Oh, Tony. Oh, we've got that lovely image within an image, that hypnotic image within an
Well,
image within an image.
no. I'm doing my best. Oh my
There you
goodness.
go. Oh, wait. Stay there. No,
Don't.
not
No,
it.
don't. Caroline, just leave it there and let me try and share my PowerPoint. That's what I want to do.
God, I love these professional. Well, I'm nearly 60. Tony's a little bit older than 60.
Caroline,
we are YouTubers. And we are YouTubers. Now I'm gonna beef us up here, Tony. We are YouTubers on the Maths Toys YouTube channel. But as you can see, it isn't. Oh! Here we go. Yes, got it. Yes, we did it.
Okay.
Is that it? Now, if you play it,
right.
If you play the PowerPoint, we should be good to go.
Well, that's what I'm trying to do.
I'm not going to tell you about what happened with our recording earlier. It can be fixed, but it wasn't quite what we expected. Oh, hello. Oh my goodness. Someone needs to go to the hairdressers.
Now can you see it?
Yes, absolutely. I've got X's and crosses.
Okay, now this is the first game that we're going to play this afternoon and show you how to play it. Now, what it is a very, very simple game. And you have a bag and you put some red cards and some green cards into the bag. And the beauty of this game is you can play it with 4-year-olds or any age. You can play it with any number of people because either, they can all decide individually whether they're going to be reds or greens, or no, actually, whether they're going to be sames or difference. I'll tell you about sames or difference in a minute. Or you can have 2 teams and somebody speaks for each team and it's one team against the other team. So my problem is, Caroline, that I don't know whether you can see the bag.
We can see the bag.
Oh, well, okay, so I can't, but that doesn't really matter. Now, what I'm doing is I'm picking 2 cards out of the bag. I'm not looking. Can you see now, Caroline?
Yes,
now,
got.
Oh, Caroline, are you going to be a same or different player?
I want to be a same player. I'm going to make
right.
It
there's
same.
Your card.
Hey, I got a point. Right, make me.
Right now, I'm going to now. The point, the rules of the game are this: that we shake the bag, and now before I pick out my next 2 cards, Caroline is going to say, well, you're going to stick it as the same player, aren't you, Caroline?
I'm going to stick the same player.
Right,
yeah.
now here are the next 2 cards.
I've got a good feeling about same player.
Oh, wow, Caroline, you've won again.
Woo! Oh, my goodness.
It's your lucky day.
Yeah.
Okay, now I'm doing very badly. Ooh, shake the bag, and now I'm going
to
pick...
Tony, good luck.
Now I'm going to pick out my 2 cards again. Okay, and...
I'm defying the odds.
Okay, this is very, very strange.
Really?
I promise you, I didn't put...
going for same must be the key to winning this game. It's got to be.
Right,
obviously.
Caroline, here we go next time. Oops. Now, this is the very last time, Caroline. You've won 4 times.
Won. I think I've won this game.
And I haven't won at all. And I'm mixing these cards up in the bag, mixing them up, and I'm taking 1, and now another 1.
Will it be red? Will it?
And they're different. Now, the result now is 4-1. So Caroline has definitely won, but that hasn't really answered our question, the question at all, as to whether it's a fair game.
Well, it can't be fair. Obviously, choosing the same makes you guaranteed to win. That's just obviously 4 out of 5. That's proof, isn't it, Tony?
Well, no, not at all, Caroline, because
Oh,
basically, if we had tossed a coin and you got 4 heads, next time it would be just as likely to be a head as a tail. And that would have been a fair, absolutely fair, because when you toss a coin, unless you're some sort of conjurer, it's 50-50 chance of a head or of a tail.
so this game is weight must be. My conclusion from this scientific experiment is that this must be weighted towards the same.
Well, it looks
My
like it.
choice.
But you see, if you only have a small sample, that doesn't prove anything. You would have had to play this game about 100 times to begin to get anything like a good indication of how the game should work out in the long run. Now, we're going to talk about that a bit later.
Sample size matters, huh?
We're going to talk about that a bit later. So this is just an example about what you would get if you opened up this learning pack, and you would get worksheets, you would get templates and instructions for making resources. In other words, this time you would get those colored cards, and what you'd actually get is you could print them out, and if you printed them on card, they'd be cards. You could cut them out, and then you're ready to play. You would get notes for teachers with solutions, curriculum links, which is telling you what topic in the curriculum this is relating to. You get some suggestions for teaching and key questions. Now, key questions are hugely important, aren't they, Caroline?
I absolutely love your quick key questions, Tony. I am not a trained teacher, and I kind of put myself in the position of the parent. Well, my position really is the grandparent, although I've got a lot of experience facilitating the learning of maths. But those key questions give you so much power to help the young person work it out for themselves.
And that is the key. That's the important thing. You see, old-fashioned traditional teaching, and most of us have experienced that in one way or another, and some people, that's all they've experienced, depended very much on the teacher explaining something and the children listening and supposed to be remembering what the teacher had said and understanding. Does that ring a bell, Caroline? Does that mean much to you?
So in my day, it was write things down on the blackboard, then you write it down in your book, and then you write down 5 or 6 questions that you've got to answer that are ever so slightly harder than the previous one. But in many cases, zero understanding, just learning by rote and parroting back. And if it became ever so slightly complicated or came out in a different flavor, totally lost.
Well, Caroline, you and I are the older generation. We survived that. I'm not saying it was a super education, but we were okay. But a lot of kids weren't, because they struggled with maths. They didn't understand what the teacher was explaining. They tried to learn it, but they didn't really understand it, and then they forgot it.
Which actually describes, in some cases, not myself. I was lucky to understand some things, but there are many things that I'm just like totally clueless. And to this day, I'm still totally clueless. And even if I learn it as I did with this exercise yesterday, today it's all gone again. But I will persevere. Perseverance and determination.
But you see, what worked a little bit, not terribly well, but it certainly served a purpose in the 1960s, is like ancient history now. Now, I mentioned the 60s because that's when I started teaching. Now, in those days, what was a computer? It was a human being, okay? Not a machine, not electronic. Very often it was a woman, and you work things out, and you should get it was important to get the right answer. And you did it as quickly as you could, so you practiced a lot so you could do it quickly. Now, those days are long gone. Now computers do all that routine calculations and stuff so much quicker, so much more accurately and reliably than people. They don't forget. And what's more, computers do a lot of other things that have taken away jobs that used to be jobs that human beings did. So it's extremely important to teach children these days life skills, transferable skills of problem solving, of using and applying what they've learned, doing the calculations very often with a calculator, and applying what they've learned to real life situations, working in a team if it's a big job, and sharing the work, collaborating with other people, being able to explain what you've done to somebody else. All of those things are much more important now than just being able to carry out a procedure and get an answer.
And the key questions in these learning guides give you the questions to ask to bring that out in your young learners. If you're a parent, a grandparent, an older sibling, or even a teacher, and you're not sure the best questions to ask, they're right here in the key questions on these learning guides.
So we suggest some key questions. And then the other thing in the learning pack is called an Inclusion and Home Learning Guide. Now, we produce one of these almost every day for you. And the idea is for you to use this at home if your children are not in school and you need them to be doing something with their time that's constructive.
And we'll talk more about the home learning guides and the inclusion guides straight after the break, Toni.
Okay.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us, yeah, 24 hours, and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back to the Happy Maths Hour with Toni and Caroline on Relax Radio. We're talking about doing probability by playing games with odds and evens and other games in a moment. But right now we're talking about the learning packs that Toni has written. And these are all freely available. We've talked about the key questions to help children learn more effectively modern day skills. And now, Toni, you're telling us about the Inclusion and Home Learning Guide that are included.
Yes. The reality of today is that lots of families have kids at home, they're not going to school. Now, if they're getting set work from school, great, but some of them are not. And what we're providing is you can use this with a smartphone. You can download from our website a PDF which gives you this inclusion guide from using a smartphone. Ideally, you would print it, but if you can't print it, then you need to read it on your smartphone. What it gives you is a starter activity that everybody in the house that's going to be can join in and do together. And often a game, but not always a game. And then it gives you different learning activities to suit all ages and learning and attainment levels from age 4 to age 18 plus. Now, the leader of this group could be an older teenager, and they will get a lot out of explaining things to younger kids, or it could be a grown-up. You don't have to be a teacher. And inclusion means there's something in that pack for everybody, for the children who are struggling a bit with the ideas, and for the children who think, oh, this is easy, I can do this. And then there's more challenges for them. So that's your inclusion guide. Teachers will use that too, because in every class in school, there's children of different attainment levels. And so now we're going to move on. And next slide, I thought you might like to look a bit more closely at this one, because it's quite interesting. If you look at the top right, how many students do you think are in that class? It's a lot, isn't it? It's probably
more than 60.
Yes, yes. And that's a typical class in South Africa and across Africa, actually. If you look at the bottom of the screen there, you'll see there's another class that's, you can't see the children at the back, they're so far away. And on the left-hand side, just by the Y, there's another big class. Okay, that is typical.
I'm always interested, and I haven't heard yet. I'd like to know about the Bangladeshi schools. I know there's a lot of Bengali listeners on this radio station. I'd be very, very interested. Please do write in and tell us about the schools in Bangladesh, because it's not just Africa, and we'd be very interested in hearing, because we do have a global network now.
Indeed.
And so, yes, please do write in and tell us about the needs in Bangladesh.
Now, most people have heard of Mandela, and you'll see him at the bottom there reading with some children. And one of the things he said was, education is the most powerful weapon which you can use to change the world. That really is my sort of engine, what drives me, because I am just so sad about the poverty that I see in South Africa and elsewhere in Africa. It's just sad, and it should not be. And the best thing I can do is to help children to get a good education, which will give them a chance of a better future, at least an opportunity, perhaps, to get a job and a better future. Now, if you look at the top, towards the right-hand side, you'll see a street there. There's a woman carrying something to take water on her head, and you'll see that street. Now, that's within walking distance of where I live in the Western Cape. Actually, that area is quite rich, and the contrast between the way some people live and the way other people live is just, I mean, it's just so wrong. I can walk from my flat, which is a lovely, comfortable home near the beach, and I can walk to that township, which is on the edge of Fishhook. It's about half an hour's walk away. And there it is. And I want to give children in schools, in communities like that, the opportunity to get a good education and a better life. And the only way I can do it is by helping the teachers, empowering their teachers to be better teachers.
So Marta's talking about training up education is the best education. Samad, if you would tell us, can you maybe include a link? You talk about Farlow, and I don't know anything about Farlow, so would you put in a link to let us know what it is you're referring to, so that we can look into it? I really don't know anything about the aspect you're talking about. Now, when you talk about training up education as the best education, that is essentially what we're doing. We are the mathematical learning activities that Toni has written are there to help the children and the families and the teachers with the children, to help them learn to think, essentially. And learning to think is the one absolutely crucial skill that everyone needs, no matter what career path they end up.
Absolutely. We have AIMSEC has a small African team working in the Cape, South Africa, and there are only 6 people in that team. And then we've got a group of volunteers like Caroline and myself, and quite a few others around the world who work as unpaid volunteers to help AIMSEC. We work with hundreds of teachers, in fact, many, many hundreds of teachers. We've already trained more than 2,000 teachers. They do 7 courses, and then they are themselves subject leaders, and some of them are lecturers and on our AIMSEC courses. And they all work in schools in communities that are very poor, like the one you see in the top, near the top right in that picture. So this is why we're asking you to donate to AIMSEC, because it's very, very hard to raise funding. we're in a difficult time at the moment. AIMSET may have to close down for lack of funding. And if everybody who just used our resources were to give just $1 or £1 or €1 or the equivalent, that would soon add up, and it would help us, because these teachers often supporting not just their own partner and children, but their brothers and sisters and their children and their parents. That's the way it is in Africa. They actually there's not enough jobs for people. A lot of people don't have work, and those who do have work, like the teachers, have often got a big family to support. Now, just before we move on from this, look at the little one in the right near the bottom there. She's actually crying, and I felt very bad about that, because I was visiting in a very small village up in Uganda with my husband, and I did wonder if she was crying because of this frightening white woman in the room.
You are very frightening, Toni.
Oh dear. So,
No, you're not.
what
You're
a
lovely grandma.
What are mathematical games about? Well, actually, they're about playing for fun, primarily. And Caroline and I try to make maths enjoyable for everybody, not frightening. And one of the points of games is that people want to win. And so, well, the motivation is if you do some mathematical thinking, you'll have a better chance of winning. And so, in a way, they're going to be playing to learn. It's not all games. We produce games at the weekends and more serious lessons in the week. And then this dissemination means how is this going to be? How are you going to get it? How are we sending it out? Well, first of all, there's the Aiming High website, where all the learning packs are. And then there's the app. Now, the app's so important, because on the app, you can download the app, okay? Go to Google Play or the Apple Store and search for AIMSEC, and you'll get the app, and then you can download everything for free. There's more than 400 different learning packs. You can download them, and then you can use them without having to be connected to the internet. And it's on Creative Commons, which means that you can change them and copy and paste. Now, we've also got a YouTube site, and there's videos there. They're short videos that you can use at the beginning of a lesson. And once a year, we have this enormous global maths and science lesson, Caroline, don't we? We're aiming for 100,000 children this year, aren't we?
Yes, I'm not sure we've ever had anyone from Bangladesh yet. We had a huge contingent from India one year. We always have people from India. And and we have people from Africa. We have people from South America, from just literally all over the world. And yes, please, well, we're going to be putting out a link to register for that in the not too distant future. But when you hear about it, in September, when you hear about it, please do join us. It is a simple 30-minute lesson, and it'll be based on games this year. Games is the theme of basically we're really into games at the moment. And it will be playing mathematical games and helping the children love playing the games, and the grown-ups, the teachers, to learn how to teach through games. Yeah.
And now the network, there it is. You can see their topic search. You can put in your topic and find something on the maths you're trying to teach, going to be trying to teach next week. And the keyword search, if you remember something, you could go there, or you remember one of the names. There's also this, we just talked about the app. There it is. It's slightly different layout to the Aiming High website, but there again, you can search and you can join in discussions. And now we're back to the red and green games. Okay.
Right. On that note, we're going to have a quick break, and we're going to be playing games to make maths fun, maths enjoyable, to think, to learn. Straight up.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. 24 hours. And let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back to the Happy Maths Hour with Toni and Caroline. Today we are playing games about probability, but this isn't odds and evens, is it? This is green and red cards in a bag.
Yeah. Now, in case you weren't there at the beginning, this was the first game we actually played it. We're not going to play it again, but you put some green cards and some red cards in a bag, and the game is simply to draw out two cards without looking at them. And if they're the same, one player wins, or one team. And if they're different colours, then the other team wins. And the question is it a fair game? And so do you have an equal chance of either getting two cards the same colour or two cards different colours? And we are going to leave you to play the game and try it out and see what you find out about it. And you'll agree, I hope, that that's a game that you could play with very young children. Now, we wouldn't expect young children to understand what some of you, if you're actually able to see this, you can see a chart with lots of rows and columns, and I'll describe it for those people who are listening on the radio and can't see it. What it shows is 5 red cards and 5 green cards. Across the top, that's the top line, and going down the side, the 5 reds and the 5 greens are in this table. And then each little box or cell in the table is positioned so if you look across and down, you'll see that you either have an S for same, if they're the same colour, or a D for different, if they're different colours. And you also have some crosses. Now, the crosses are because you don't put the first card back before you take the second one out. You take them 2 out together, so they actually are 2 different cards. You can't count the same card twice, and so that's not an outcome that's possible. So there are 90 possibilities, and you can see from that, if you're looking at it, that 40 of them will be the same coloured cards, and 50 of them will be different. So it was really weird when we played it, Caroline, at the beginning, because you.
Yeah. Well, I chose the last time we played it. I actually chose different every time, and of course I don't think I won either the first time. And this time I thought, well, I'll choose same, then that way for sure I'll lose. And I didn't. I won that out. But you can see from there that well, I was defying the odds.
Well, you were lucky because you won 4 times, and I only with same. And actually, your chance of actually getting 2 cards the same was less than me getting different cards, but you actually won. So that just shows that if you only do the experiment a few times, it doesn't show anything necessarily that's anywhere near reality.
It's not truly representative at all unless you have a decent sample size.
Yeah, well, what that means is that you do lots and lots of experiments. You play lots and lots of times.
Yeah.
And of course, this idea of probability is more important now to us all than it's ever been because of COVID and the fact that we are often seeing something about statistics and graphs, which are models, they're mathematical models of medical tests that are carried out. Now, you can't be a theoretical probability because nobody knows what actually happens, and they do the medical or clinical trials to find out. And so what they do is to give some patients supposing they're testing out the vaccine, they give some patients the vaccine, and everybody gets an injection, but some people the injection's just saline solution or something like that, and so that's what we call a placebo. It might work, it might not work. So that's what they're comparing, and they have to test thousands of individual people. Each one, in a sense, is like an experiment in themselves. Each individual is like an experiment, and they've got to test thousands in order to get a true indication of how it will work out with the whole population. It's a mathematical model, and so that's how mathematical modeling, very briefly, how it works. And it's quite good for children to get an experience of that. So by the time they're beginning in secondary school, I would be introducing them to this sort of table by the time they're 11 or 12. Now, younger children, however, can still play the game and decide whether it's fair or not. Now, I have experienced, I mean, I've known lots of little ones, and when they're 4 or 5, children can share a bag of sweets and make sure they get fair shares, can't they, Caroline?
They most certainly can. They certainly will know if they're not getting a fair share.
Yes. And equally, if they play a game and it doesn't seem that, one side wins very often, they'll soon be able to work out that this game isn't fair. And so what all this is about is now a different sort of game. We played the red and green game. Now we're going to play a slightly different game, but it's still about putting cards or balls in a bag and picking 2 out at random. Now here you see the balls or the numbers for 4 games, and they're all played with the same rules. And the question is, are any of these games fair? So in this case, if the total is even, you win, and if it's odd, you lose. And the question is it a fair game? So game A, you've got 2 odd numbers and 3 even numbers.
Yep.
And the question is, play it, try it out, test it, see, it's like do the experiment over and over again. Is it a fair game? Okay. And then you can do the same with the balls not like numbered like you see there for B. Now B has got 1, 3, and 5, which are odd numbers, and 1, 3, 5, and 7.
Yeah.
Numbers, so 4 odd numbers and 1 even number. Question is that a fair game? With C, that's got 4 even numbers and 2 odd numbers. Can that be fair? And with D, that's got only 1 even number and 5. Is that right?
Yeah, 5 odd numbers.
Well, I think it must have been 5 and 1. No, it's
all the odd numbers. 1, 3, 5, 7, 9. All the odd digits.
Okay, so each of those sets play the game. Now, you'll agree, it's a different game from the reds and greens, but there's similarities between the 2 games, and then we're going to find out something a little bit strange about that later on. This is the sort of thing you can do in maybe just 5 minutes or less at the beginning of a lesson. And you can ask some questions, you can get the children thinking about this. And it's not something that you can just do once and think, well, that's done, don't need to go back to that thing, because it is actually very useful. Now, where does it all lead? Now, this is a big secret, okay, but I'm showing you, I'm giving away the secret, because I'm hoping that this will surprise you, and you will, it's quite counterintuitive actually, and that I did say that this set of games was actually suitable for all ages from 4 to 18. If you're teaching upper secondary, university, entrance standard, then we're going right through to that, because by that time, the student should be able to prove that it will be a fair game if the numbers of odds and evens are 2 consecutive triangle numbers. So, for example, if there were 3 odds and 6 evens, then that would be a fair game. If there were 3 odds and 1 even, that would be a fair game. And then 2 consecutive triangle numbers, well, 15 and 21 are consecutive triangle numbers. And the same applies there. So if it was 15 evens and 21 odds, or the other way around, it would be a fair game. Now that's it seems strange, doesn't it?
It seems very strange. It messes with my head, I have to say.
Oh, Caroline, I don't like to mess with your head.
Actually, no, isn't that what you're supposed to do? Get the thinking, get the juices flowing.
Well, there you go. Now, whether you teach 10-year-olds or 18-year-olds, it's a good idea if you actually know where this sort of thing's going. And what's so important is that the basics, the sort of foundation work, are laid early on. So children are understanding a bit more about probability as they grow up, and that it's not a big mystery to them. They actually become more comfortable with it as they get older, and everybody is understanding more and more. This is what we call the spiral curriculum. You keep coming back to the same sort of idea again.
And I love that. I love the spiral curriculum. What a great way of describing it. That I've got one of my young tutees has complained to me. He says, "Why do we have to do the same thing again and again? Every year we do the same thing. Why can't we just do it all at once?" And it's because you can't take it all in when you're 7. It takes time to accumulate and come back to it and then readdress it and keep spiraling up and adding a little bit more at a time. And then if you've missed any, it gives you a chance to recap and capture something that you didn't capture the first time around. Absolutely.
And the point about it is that you do add something each time. You do make progress each time. When I say you do, the children do in their learning. And as a teacher, you've got to make sure that if they don't remember what they did when they were 7, you can remind them or give them a task which will take them back, and then they will make sure those basic ideas are there. And the thing about maths is it's not like other subjects. If you don't know the basics, then you've nowhere to go, because everything's depending on something you learned earlier.
Okay, we're going to go for a break, and on that sobering thought, what are we going to be doing after the break, Toni?
Well, we're going to look at this picture, Caroline, and see what we notice about it, why the triangle numbers are called triangle, and also what we notice about this pattern 1, 3, 6, 10, 15, 21. And could we say what the next triangle number will be after 36?
Oh, nice one. So we've got some real food for thought during this break, and we keep having your ping for the break. Here we go. See you after the break. So keep mulling over that. Well, you won't see the picture, but record that picture in your head and mull over it during the break. Be right back.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us, yeah, 24 hours, and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Now, triangle numbers are amazing because they crop up so many times. I mean, just again and again, you're doing something that is not like the other time you remember triangle numbers cropping up, but oh my goodness, here they are again, triangle numbers. Okay. Now, Caroline, what do you notice about the pictures that you see there?
Right. So what I notice is that the T1 to 4, the numbers form a triangle, starting with, and then they go across 1, 2, 3, and 4, and they increase by 1. And then the next row down, everything's a rectangle. And you've got, like, you've basically doubled the triangle to form a rectangle.
Yes, and this is a big clue as to how you might find the next triangle number after 36, because each of those rectangles is a little bit bigger, okay? And so when you have number 4, which is triangle number 4, which is for which we found out is 10. Okay, well, now we can count them, but the point is once we get a very big triangle numbers, we're not going to be counting the dots. We should have a formula that will tell us, okay? And how can we get the formula out of the picture? Now, how many dots in the rectangle is the big key, the big question.
How many dots in the rectangle? I did look at this carefully earlier, and there are basically double the amount of dots in the rectangle as there are in the triangles.
Absolutely. And also, what about the rows and columns? Because if you're going to see how many dots in the rectangle, you can count them. Or you can actually work them out as so many rows, and how many, that's how many columns there are. So
the rows are the same as the triangles, and the amount of columns is, no, I didn't get there last time, did I? The amount of columns is one more than the amount of columns in the triangle. I hadn't noticed. That didn't click last time. You've only got, I was thinking it would have twice as many columns. It doesn't. It only has one more column than the original
yes,
triangle.
It's sort of slid sideways, isn't it? The purple one slid sideways.
It's kind of filled in and added a column,
exactly.
but not a row. It's got the same amount of rows, but one extra column.
So number 4 has got 4 times 5 dots.
Yes, 4 times 5. Yes.
And number 15 has got 5 times 6 dots.
Okay,
oh well,
so
it hasn't. It's got
Yep.
yeah, but that's double the triangle number.
Yeah.
So it's 5 times 6 is 30, and half that is 15.
Yeah.
And then 21 is 6 times 7, which is 42, and half that's 21.
Yes. Yeah.
And so it goes on. So after that, 15 is the 5th one, 21 is the 6th one, 28 is the 7th one, 36 is the 8th, and so the next one is the 9th. All right, so it's 9 times 10, and then you divide that by 2.
So it'll be 45.
And so you can always work out the triangle number. So it's n, which is where it is in the line. It's number 4, 5, 6, 7. That's its ordinal position, in the order. And then add 1. So it's 1 more column than there is row. It's n times n plus 1, and then you halve it.
Half of n times n plus 1. Okay, right. So you've explained that very beautifully now, and then we went into using algebra, which might befuddle some people. So can you just repeat one more time when you said it in English? Because I thought you said it so
it's the number of rows times the number of columns to give you the number of dots in the rectangle, and then you divide that by 2.
And you can see that is just obvious, isn't it, just by looking at it? But and the +1 is that there's always an extra column every time.
Mm-hmm.
And it's still, and then that's all divided by 2, so it's great.
So children meet triangle numbers pretty much as soon as they may even meet them in primary school, but they certainly meet them early on in secondary school. And of course, it's just adding 1, 1 + 2, 1 + 2 + 3, 1 + 2 + 3 + 4. And they, as I say, come up again and again.
Well, I've encountered those just by doodling. When I had no idea what I was doing, doodling is a great way of discovering patterns, and I absolutely discovered the triangle numbers just by purely doodling on my square paper along the margin. And so you discover triangle numbers without even knowing you're doing it.
Now, why have we put together these reds and greens and these odds and evens games? Well, this is something absolutely wonderful about maths, that very often the maths you meet is in something you know about and you've met before, but now it's in disguise. It's looking a bit different, but it's really the same as something you met before. And perhaps you've noticed it in listening to what Caroline and I have been nattering on about. The reds and greens are like odds and evens. And the games are quite similar because basically we have cards or balls or whatever. We've got them in a bag. We've got some number of one type and some number of the other type. And we pick out 2. And if the total's odd or the total's even, or in that game, or if they're both red or both the same color or both different colors in that game, then according to which it is, you win or you lose. So we've played the games and they didn't seem the same, did they, Caroline?
They didn't seem the same at all. The one with the numbers seemed a lot more elaborate. I suppose you went that extra step to discover the triangle numbers and then looking for an algebraic expression, a generalization, as the mathematicians would call it. But the essence of the game, no, I didn't.
But you see, the triangle numbers apply to the red and green just as much as they apply to the odd and even.
Oh my goodness. Okay, here we go again. Those games are the same games, really, but actually in a slightly different form, slightly disguised, but they are the same. Lovely.
Isn't that beautiful?
We can derive the triangle numbers.
Yes.
But it's through the triangle, right? Okay, so for the triangle numbers, you're looking at how many reds versus greens are going to give you a fair game. It's a search for the fair game, isn't it? The triangle numbers.
So if you had 3 reds and 6 greens, that would give you a fair game because those are 2 triangle numbers that
so they're consecutive. So it goes 1, 3, 6. So 3 and 6, 3 reds, 6 greens, or 3 greens, 6 reds, and then the next one is 6 plus 11. Is it?
No.
No, what is it? 10. 10 is 10.
Yeah.
So 6 and 10, 6 of one and 10 of the other would also give you a fair game. Yeah. Okay, so those triangle numbers are, it's like the triangle numbers are the key, and yet it's the chicken and the egg. It's not that one causes the other. It's that it's the beautiful pattern that gives you the result. And that's the beauty. That's the beauty of maths, isn't it? When things
is amazing
work out like that.
And the way to sort of to play this as a teacher is not to sort of do these games so many times that people get bored, but to just start the lesson by playing the game once or twice, and then next time you're doing some probability, play them again. And there seem to be different games here because you've got different numbers on the balls, and get the children to, once they begin to understand, and they will work it out for themselves. Let them work in pairs or small groups. They'll work it out whether it's a fair game or not. I assure you they will. And then get them hunting for, how do we get a fair game now? And then if somebody thinks, oh, I found a fair game, you have whatever this is, they may say, oh, if you have 3 odds and 6 evens, it is fair. And then the whole class can play it a few times and confirm that it seems to be. And so then you begin to find a few fair games, and then you begin to think, wow, goodness me, what's going on with these numbers? Now, I assured you at the beginning that this was going to be suitable for your 18-year-olds. And it will, because we're going to ask them to prove why triangle numbers give you an answer. And there's quite a bit of help with this in the Inclusion Home Learning Guide. So it's going to be challenging for your 18-year-olds who are about to do their school leaving exam, 18, 19-year-olds, just as much as it is for 5-year-olds who can play the red and green game. Yeah. So these are on our Facebook page, on the AIMSEC Facebook page over this last weekend, and look at the Inclusion Home Learning Guide, and you'll see a lot more about these games.
I'm just going to put the link there. There we go. To the Aiming High. So that's your link to the Aiming High website, where you actually will be able to download all of the resources. And then you've got, of course, the app, which is the Aiming High app. And then
you'll see all these things, the sort of starter activities on Facebook, and it's facebook.com. Here it comes, facebook.com/AIMSECSA.
So those are just little snippets, just to get your juices flowing, or just to do something little every single day. And then
look at today's, Caroline, and that's the answers 2021. What's the question?
Yeah, that is a nice one. I'm going to have to have a go at that. So today's, go to facebook.com/AIMSEC, that's AIMSSECSA, and do today's activity. Any question you like that has the answer 2021. I'm going to go and have a go at that now. Well, thank you so much, Toni. Thank you, everybody, for listening. Thank you. We've had some great participation with Samad. Oh, Toni Beardon, Samad says you were excellent.
Oh,
and,
nice.
The puzzle game. I'm not quite sure what you meant by the puzzle games, Samad, but if you go onto the AIMSEC SA Facebook page, then you will find all kinds of games and the links to the more in-depth activities on the Aiming High website are all on the AIMSEC Facebook page. So thank you so much. I hope you join us again next week. That'll be fantastic. Thank you, Toni.
Bye-bye, everybody.
Bye-bye, everybody. See you next week. Same time for the Happy Maths Hour.